Well, first, thanks a lot for the opportunity to share a bit about the U.S. Forest and harvestwood product carbon picture. And I'll zero down a little bit on entity level reporting, but broadly speaking, I'm going to give sort of the latest and greatest information on the state of forest carbon and harvested wood products in the United States. So I'm a research forester and group leader in the U.S. Forest Service Forest Inventory and Analysis Program. I'm the lead scientist and lead inventory compiler for the forest land and harvested wood products category in the U.S. And so most of the information you're going to see today was compiled as part of our Forest Service group. And I should acknowledge, while I'm the one speaking, this work is done by a large group of people and partners between the universities, many universities, Forest Service, as well as non-government organizations. So thanks a lot for the opportunity. So why is this important? So this is a carbon forum. So most of you have seen these curves in the past. This is really a reflection of CO2 concentrations in our atmosphere going back to pre-industrial revolution days. And you can see here that really post 1950, but really starting right around the time of the Industrial Revolution, there was this marked increase in CO2 concentration in our atmosphere. And so early on, more than 100 years ago, these concentrations were identified as being potentially detrimental to human health, as well as the environment. And so in the late 1980s, early 1990s, the United Nations Framework Convention on Climate Change acknowledged this and was established. 197 countries have ratified the convention. And really the whole point and thrust behind this was to act in the interests of human safety, even in the face of scientific uncertainty. And this language comes from a report back in the mid-1990s, but I think these quotes really hold true today. We know a tremendous amount more than we did in the mid-90s, but there's still a lot we don't know, particularly around the land sector. But really the goal here is to reduce or prevent dangerous anthropogenic interference with the climate system. And so as part of the United Nations Framework Convention on Climate Change, the US is a party to the convention. We have a requirement to provide an economy-wide report on the emissions and removals of all greenhouse gases each year from 1990 to 2 years before present. And that report was just published and submitted to the United Nations in the middle of April on tax day. And so I will be describing some of the results from that report and also what it means at a finer spatial resolution from states all the way down to entities. So a little more context within the land sector. So I'm really going to focus this talk on forest land and harvested wood products. And so this overly simple cartoon really illustrates the different components included in the land sector and the sort of interactions between these 6 land use categories: forest land, settlements, other lands, croplands, grasslands, etc. And so there's a lot of movement of carbon between these different categories, and tracking those movements is a challenge. The forest land category, including harvested wood products, accounts for about 95% of the land sink strength and annually offsets around 14% of economy-wide carbon dioxide emissions, or about 11% of total greenhouse gas emissions in the US. So to set that on a global stage, the forests and harvested wood products in the US contribute to offsetting about 1.3% of global greenhouse gas emissions each year. So a really substantial sink in the US, although there are many opportunities to increase that sink, both in the forest, as Lauren mentioned, but also in how wood products are utilized. So the estimates I'm going to describe today are based in large part on the National Forest Inventory data. So the FIA program maintains the National Forest Inventory. The inventory includes more than 365,000 plots across the US, US territories, including Alaska and Hawaii. I've just shown the continental United States here. The top graphic on your right is the area of forest land, or the distribution of forest land in the US. And the lower graphic is the approximate FI plot locations in the US. So you can see a very robust coverage of the forest land base from these permanent sample plots that FIA maintains and remeasures every 5 to 10 years. The inventory, because of these permanent plots, is really designed to be a longitudinal look at the status of not just forest land, but all lands in the US. And so we can track a variety of different attributes, including disturbances, but also estimate and model ecosystem variables like growth, carbon sequestration, mortality removals. And so that's really the information that is used to characterize carbon stocks and stock changes in these different forest components. So above ground live biomass, dead wood, both standing and down dead, litter, and then soil organic matter, both the mineral and the organic soil are really the principal components or key ecosystem categories that we're interested in characterizing, and the transfer of carbon between these categories, other land uses, and also through to harvested wood products, and as well as the atmosphere. So here's a look at the carbon stocks in the US by those forest ecosystem carbon pools. And we've included what we often describe as the sixth carbon pool, which is harvested wood here. And so you can see that forests store a substantial amount of carbon. So I recently did a calculation, and the carbon stored in forests right now would offset more than 30 years of all automobile emissions in the US. And so it's a substantial sink, and the sink strength is also very strong. And that's where we get at that sort of annual offset of emissions. So an interesting point here, the stock of harvested wood products makes up a relatively minor component, proportionally about 5% of the total carbon stored collectively in the forest and harvested wood products pool. Moving on to fluxes, the harvested wood products pool plays a really substantial role here. And while it's a disproportionate, it's a relatively small component of the total carbon stocks, around 5% of the total carbon stocks in forests and harvested wood, it accounts for about 15% of the sink strength. And so on an annual basis, harvested wood alone accounts for about 100 million metric tons of CO2 equivalent uptake or transfer from forests and maintained in those harvested wood products, both in landfills and products in use. So this graphic includes all of the components that our Forest Service team contributes to this the National Greenhouse Gas Inventory Report each year. So it's really a time series, or a truncated time series, of the emissions and removals associated with forest land, land conversions to and from forest land, as well as carbon emissions and removals associated with woodlands and urban trees and settlements, which is a pretty substantial sink. And the sink strength in the urban setting has actually increased in recent years. And that can be attributed in part to conversions from forest land into that settlement category here. You'll also note that in general, across all of these components that we've included here, the sink strength has declined since 1990. And there are a variety of reasons for that. Lauren touched on one of them, which is disturbance, particularly in the Western United States, has led to substantial interannual variability in this time series, but also into a diminished sink strength over the last nearly 30 years. So this is another way to portray the data I just showed, just at a state level. And so this graphic comes from a released a report documenting state level emissions and removals for the forest land category and urban trees. And you can see that there are some major winners in terms of their sink strength, their annual contribution to the overall national carbon sink. And some of those above that zero, which a positive number here reflects an emission, there are some states, particularly in the Western US, that are currently sources of carbon. And so there are opportunities there to avoid emissions through forest management practices, again, mentioned by Lauren. So I built this presentation around a number of questions that were raised or presented to me. And one of the questions was, what is the current status of forest carbon and stock changes by ownership patterns, and how does management on different ownerships contribute to changes or differences in the forest land base, particularly around carbon? And so that's what this graphic broadly highlights at a national level. And so you can see here that public lands, particularly federal lands, generally on a per unit area basis, store more carbon in live biomass than state or private lands. That being said, it's really the opposite in terms of annual sequestration. You can see that private lands generally sequester on a per unit area basis substantially more carbon across all stocking levels in the US. So it's sort of, this kind of relates well with that first graphic that Lauren showed, describing this sort of continuum from really intensive forest management over to old growth, and the contributions of those different stages and complexity of forests. So, this first graphic, or the top graphic here, really describes just above ground biomass. But if I were to include all carbon here, the picture would look very similar. And the same would be true for below ground, where really we've focused on live trees here because that's really the pump in the forest. It's the live trees and live vegetation more broadly that are interacting with the atmosphere and sequestering carbon from the atmosphere, and then storing that carbon in both live and dead material, which ultimately accumulates in forests and results in that large sink strength that we just described. Now to focus in a little bit on harvested wood products, which was another question. How do we account for harvested wood products, and who is responsible for the emissions or the removals associated with harvested wood products? Well, this is really, I'm going to take an angle from a national reporting perspective and really international reporting. There are basically three broad methods which have been established to estimate harvested wood products and the emissions and removals associated with those products. The first is the stock change method, which includes all harvested wood consumed in an area, so in this case, the United States, regardless of the origin. And we only include the emissions here from the wood that was domestically produced. So we include both the emissions from that wood that was exported to, for the production approach, but we include only the emissions from wood domestically produced. Whereas in the stock change approach, the imports are included and exports are excluded. So that's really a difference between stock change and production methods. And then the atmospheric flow approach, we incorporate basically direct emissions directly based on the annual atmospheric flux. So a variety of things are included in the atmospheric flow approach that are not included in either the stock change method or the production approach. And it's really important from sort of a jurisdictional perspective that, for example, if the United States is exporting wood to Europe, that Europe is also using a similar approach to account for the emissions and removals associated. So you can imagine in the US, if we're exporting wood, in the United States, we use the production approach, but we compile our estimates using all three approaches. So using that production approach, if we're exporting wood for energy, we're assuming the emissions associated with that, with that wood utilization for energy, just like we would assume the emissions associated with paper products or cardboard or any other wood product that was produced domestically and exported. just to sort of describe that in numerical terms, here are the estimated emissions and removals associated with harvested wood products in the US over that same time series that I just mentioned across these three different estimation methods. And you can see that more or less the trends are certainly the same, but there are some departures for a variety of reasons between particularly the stock change approach and the production approach over time, with the atmospheric flow really in many cases sort of falling somewhere between the stock change and production approach throughout. And just to highlight this, you can see here in the US, the contribution of harvested wood products is substantial. Like I said, accounts for about 15% of the sink strength in the US between forest and harvested wood products. And you can see that recently with the Great Recession, the sort of the decline in the contribution of harvested wood products. But I'm happy to report that that decline has resulted in a sort of precipitous increase again in the sink strength as wood products are being utilized, forests are being managed, and products are coming off of those forests. That sink strength has returned to basically pre-Great Recession levels. A few final thoughts on this, and like Lauren, I'd be happy to discuss these things in more detail in the discussion. Forest Service continues to expand our role in greenhouse gas estimation and reporting, not just at the national state level, but also contributing to a variety of entity level assessments. The FIA data that I briefly described here really serves as a foundation for the work that we do. But as we work to develop more spatially and temporally resolved information, we focused a lot on integrating auxiliary information like remotely sensed data from satellites and fixed wing aircraft into our analyses to be able to resolve those estimates even further at that sub-state level. We continue to improve and expand our capabilities, and to do this, collaboration and partnerships have really been important. And finally, all of the work that we do is really to inform policy and land management practices across the scales that I mentioned here today. So with that, I'd like to thank you. And now I will stop sharing, and I'd like to turn it over to Monica.